Good evening, gentlemen, and good evening, viewers. In the last class, I told you about the coefficient of correlation, that is, coefficient of correlation, rank correlation, all these things I told. And in the last class, so only I told you that I am going to continue this regression and other thing. Up to correlation coefficient, we'll have the first topic, that is business statistics 1. And coming to business statistics 2, what are the things that are included? I'm giving the syllabus for that, and after that I'm going to deal the various formulas that we'll come across in the various topics. Okay, in business statistics 2, that is second part, we'll come across regression analysis, then index numbers, then time series, then probability, and after that the last one is theoretical distributions. Regression analysis. The continuation of correlation analysis is nothing but regression analysis. In correlation analysis, we'll see the relationship between two pairs of observations, how we can correlate them, in what way we can correlate them, will take into account this correlation analysis. When you go for regression analysis, the average relationship between two variables, and this makes possible estimation or prediction. Okay, the term regression was first used by Sir Francis Galton in the year 1877. And what is the dictionary meaning of this regression? Regression means the act of returning or going back. We'll come across so many things, that is, we'll go for measures of central tendency, measures of dispersion, and correlation. All these things will come across. But what we have to do is we have to go back. We have to return back and see whether we are getting the correct understanding about a data or a distribution. We have to take into account that thing. So this regression analysis, it will act as a going back or returning back to the previous things, that how they are used and in what way they are related, in what way they are differentiated. All these things we will understand in this regression analysis. So the dictionary meaning of regression is nothing but act of returning or going back. And this was, I told you that this was introduced in the year 1877 by Sir Francis Galton. Okay, up to that extent, people, they used to go for the different measures, that is measures of central tendency, measures of dispersion, correlation analysis. All these things they have invented and they have introduced. But this gentleman Galton, okay, he got a doubt. We are doing all these things. Whether we can come back, whether we can go back and see how far they are relevant and how far they are good. Okay, so that is why this regression analysis was brought into picture. The line describing the tendency to regress or going back was called by Galton as regression line. Okay, so when we are going back, the line will call that thing as regression line, and it was given by Mr. Galton, Francis Galton. It is still used to a regression. It is still used to describe that line drawn for a group of points to represent the trend present, but it no longer carries the original implication of stepping back. So this regression line, it is used to find out the trend. It is used to find out the trend when we are plotting the things that we will come across. Okay, so that is nothing but the regression analysis. And what are the contents of this regression analysis? here we'll take into account two variables, x and y. It is clear from the regression analysis is a statistical device with the help of which we are in a position to estimate the unknown values of one variable from known values of another variable. So if you take into account one variable, we can be in a position to know the values of another variable. For example, if x is of one distribution is given, if you are taking x of one distribution, you can be in a position to estimate the other value, okay, the other value y, and that other value it will be dependent on x variable. When there are changes in x variable, automatically you will come across changes in y variable. So here you will come across independent variable and dependent variable. You can take any one as independent variable, thereby you can be in a position to know the other variable. Suppose if you are taking x value as independent value, you can be in a position to know the dependent value y of another variable. Similarly, if you take y as independent, you can be in a position to know the dependent variable x. So you can use in any way, either this way or that way. But one thing you have to keep in mind is you will come across independent value and dependent value. Okay, if you take one variable as independent, you can be in a position to predict the dependent variable of another distribution. Okay, if you take that as independent, you can be in a position to know the dependent value of first distribution. So that's why you will come across regression analysis or going back analysis. The variable which is used to predict, okay, is called the independent variable or explanatory variable, and the variable which is dependent, we'll call that as dependent variable, which is going to be predicted is dependent variable or explained variable. Okay, this is about the regression analysis. And what are the uses of regression analysis? Regression analysis provides estimates of values of the dependent variable from values of the independent variable. How the independent variable it is and how the dependent variable, how will be the value of the dependent variable. Suppose, for example, I am giving an example. If you take x value as 0, what is the value of y? If you take x value as 1, what is the value of y? Okay, there you will come across positive values or negative values. Mind it, there you will come across positive values or negative values. But whatever it may be, what will be the dependent value of another variable? That is the first usage. The second goal is to obtain a measure of the error involved in using the regression line as a basis for estimation. Whenever you come across any error, because I told you that one is independent and another is dependent, and sometimes there may be a chance for you to get an error, and this regression analysis, it pinpoints out the error and it will rectify the error then and there itself, because we are taking independent variable and dependent variable, so there is no chance to get this error. Suppose if we come across, then automatically the regression analysis, okay, the regression analysis is there to correct the error, okay, pinpoint the predict the error and correct the error. That is the second thing that we will come across. With the help of regression coefficients, we can calculate the correlation coefficients. See the peculiarity. Regression coefficients, that is, will take into account two coefficients, regression coefficients, bxy and byx. These are the two coefficients. That is, when x is independent, what is y? y is a dependent. If y is independent, x is a dependent. So these are the two coefficients, regression coefficients that we come across. And using this coefficients, whether we are going to get the correlation coefficient or not. This is nothing but a test. This is nothing but a test to see whether the coefficient of correlation is correct or wrong. We have to take into account this regression coefficients, and by using the regression coefficients, we can calculate the coefficient of correlation. Now, what are the differences between correlation and regression? Differences. There are differences. Correlation coefficient is a measure of degree of covariability between x and y. Covariability. That is, we'll take into account sigma xy in coefficient of correlation. Wherever you take, whatever it may be the formula, compulsory you have to multiply x and y. Okay, x value as well as y value. So that is, we'll call that thing as covariability. But regression analysis studies the nature of coefficients. Studies the nature of coefficients, how the coefficients are, relationship between the variables, so that we may be able to predict the value of one on the basis of another. That's why we can say that regression studies the coefficients, okay, how they are, and whether we can bring any relationship between the variables, so that we may be able to predict the values of one on the basis of another. Next, correlation is merely a tool of ascertaining the degree of relationship between two variables. Correlation, it will study only the relationship place, the degree of relationship. Whereas regression analysis, okay, it will take into account dependent and independent. In regression analysis, one variable is taken as dependent while the other as independent, thus making it possible to study the cause and effect relationship. In economics also, you will come across cause and relationship. Okay, what is the cause? What is the cause? And with that cause, what is the effect? Okay, what is the effect? So cause and effect relationship, it will take into account. Which one? Regression analysis. And correlation, it will take into account only the relationship between the independent and dependent variables. Now, when you go for the next thing, that is regression lines, we'll come across two regression lines. Okay, starting from x onwards and similarly starting from y onwards. So basing upon two lines, we have two equations, and those equations we will call them as regression equations. Next, here, what is the first one, sir? Regression equation of y on x. Y on x. Here, x is independent and y is dependent. Now, what is the formula? What is the equation? The regression equation of y on x is expressed as yc is equal to a plus bx. A plus bx, where y is one variable and x is one variable. X is independent variable and y is dependent variable. Now, what are a and b? What are a and b? Okay, a and b are constants. The position of line completely. The constants are called the parameters of the line. Okay, we can say that a and b are nothing but the parameters of the line. Now, one thing, it will take into account the change, and the second thing, it will take into account the parameter A determines the level of the fitted line. The parameter B determines the slope of the line. That is the main thing that you will come across. Okay, parameter A, it determines the level of the line, fitted line. Parameter B determines the slope of the line. How the slope is, whether it is vertical, whether it is horizontal, whether it is diagonal, okay, or whether it is flatted, all these things you will come to know when you go for this yc is equal to a plus bx. Now, a and b are to be obtained. A and B are to be obtained, whereas X and Y are the values that we'll come across when you go for independent and dependent values. Now, if the values of the constant A and B are obtained, the line is completely determined. The method of least squares, which states that the lines should be drawn through the plotted points in such a manner that the sum of the squares of the deviations of actual y values from the computed y values is the least, or in other words, in order to obtain the line which fits the points, okay, better or best, sigma y minus yc should be minimum. Now, in the previous expression, in the previous equation, I told you that yc is equal to a plus bx. Okay, so we are calculating y values. So that's why yc is nothing but the computed values of y, taking x as independent. Taking x as independent. Now, when you take into account this y and yc values, okay, they should be minimum. The deviation should be minimum. That's why sigma y minus yc is minimum. That is the last thing that we'll come across. Now, for this, you have to take into account the method of least squares. A straight line fitted by least squares has the following characteristics. It gives the best fit to the data in the sense that it makes the sum of the square deviations from the line sigma y minus yc whole square smaller than they would be from another straight line. The property accounts for the names least squares. So when you are taking into account y minus yc, it is minimum. When you take into account the squares, then that is nothing but the line, that is, it will decides about a straight line or a best fitted line. That is the first usage by taking this least squares method. The deviations above the line equal those below the line on the average. This means that the total of the positive and negative deviations is 0, or sigma y minus yc is equal to 0. Now, when you want to know the best fitted line or the straight line, you have to take into account the deviations, positive or negative deviations. Thereby, it will be equivalent to, the resultant will be equivalent to 0. That is the next thing. Now, the straight line goes through the overall mean of the data, that is bar x and bar y of the two variables. When the data represent a sample from a large population, the least squares line is the best estimate of the population regression line. When you are going for the population counting, then the least squares, because how many male members are there and how many female members are there, if you want to take, so the least square method is the best method that we come across. Now, when you go for this, okay, with a little algebra and differential calculus, it can be shown that the following two equations simultaneously